Welcome to the third in this series of the AKN003 videos. We're going to start this one by a brief look at the test track I've been working on for the last year or two, and then we're going to have a look at some points motor circuitry that I've designed and the operation of these. The test track itself has undergone any number of revisions during the time it's been in use, both in terms of the layout on top and more particularly in terms of the electronics, most of which is hidden away underneath. The consequence of that is that there are holes and various hackings all over the place. It looks a little bit untidy, but it doesn't matter. The purpose of it is that I can test the ideas out. I'm as far back as I can get, and the zoom is as far back as possible. And I still can't quite fit the whole layout in, so I'll pan a little to the left and the right so that you can see the whole of the test board. It's 2.4 meters by 1.2 meters, and as you can see, it consists of 3 loops with some points interconnecting them, a couple of crossings as well. You'll probably also notice that there's a piece of string diagonally across from the top right to the bottom left. That wouldn't normally be there, but I'm using it to mark, approximately that is, where the two power domains meet each other. And what I mean by that is that there is no continuous power loop at all, as you would traditionally have. Instead, it's divided into 2 halves, basically a top left half and a bottom right half. And these are joined at approximately where the string crosses the tracks. Separating the 2 power domains are insulated rail joiners. And what that means is that I need 6 independent power supplies to power the 3 loops here. The power is fed into the track either side of where the string crosses the 3 tracks at the top right hand corner. There's a knock-on effect to the powering scheme I'm using, and that can be seen at these points in the foreground. Unfortunately, I don't have any track power, so I can't show anything moving, but I can explain it using a static scenario. Top right hand corner of the layout, which in terms of the points in question means that the power is coming in from the right hand side of the picture. Both the tracks to the points are powered simultaneously. One for the GWR tank, which is stopped just short of the points, and the other one for the LNER tank, which is running through the points. If I use standard metal rail joiners, it means that the 2 power supplies would be shorted at the points. This is in fact exactly what happened, and resulted in the destruction of one of the output stages of the power supplies, which is why I haven't got power for the track. The solution therefore is to put insulated rail joiners in the outside tracks leading to the points, and then switch across these alternately as the points move. This requires that the points motor module has a relay which switches according to the setting of the points. I've designed a couple of these points motor boards, one based on the Pico PL10 solenoid motor, and the other one based on a servo motor, and the one I'm using is the Tower Pro SG90. This is the underside of the board, and we're looking at the solenoid motor. This is the PL10 from Pico here. And in this particular case, I've fixed it directly to the underside of the points. This gives perfect alignment. The drawback, however, is it leaves a very large hole in the baseboard that is more than unsightly in my opinion. It's not a good arrangement. I wouldn't put this in practice on the actual layout. In this particular instance, I haven't mounted the solenoid motor on the PCB. I could have done, there's definitely a location there for it, and a slot just here allows for the bar here to go through. The actual circuitry on the PCB is pretty straightforward. There isn't much needed to drive a motor like this. A couple of relays and their drivers move the motor in one direction or the other, down or up, and then all you need is something to control that, which is in this case a pickaxe 08M2. This board requires 3 power supplies. There's 5 volts coming in here for the pickaxe, there's 12 volts coming in here for the relay drivers, and there's the AC here for the motor itself. This is the servo motor counterpart to the solenoid motor driver. There's the servo motor itself, of course. We need a slightly bigger pickaxe. This is a 14M2, and this here is the relay that switches the power through the outer rails. The operation, if I flick the switch, is quite smooth. And if I need to, I can adjust the position of the end stops. Hold the 2 adjust buttons down for a couple of seconds to get it into the correct mode, and then adjust as necessary. And if I leave all the switches alone for a period of 10 seconds, then it goes back to normal operation. This board also needs 3 power supplies. The same 5 volt supply coming in here for the pickaxe. The same 12 volt supply here for the relay drivers. But this time it needs a separate 5 volt supply for the servo motor. It's important that this is separate from the supply for the pickaxe, because servo motors inject an awful lot of noise into the system, and it's important that this doesn't get into the digital circuitry. Right, the string's removed. I've moved the camera a bit nearer, and hopefully we can get a decent view of the operation of the points. The first one here is for the picoelectric solenoid. The motion is abrupt and comes with rather an audible noise. I'm not overly keen on it, to be honest with you. It works perfectly fine, there's no problem in that respect. But, well, that's what it is. Here's another set of points, and this one is operated by the servo motor. Let's have a look at how this operates. It's a lot quieter. It's not totally silent, but it's certainly an awful lot quieter. And the operation is smoother. This I much prefer. There is a bit of a problem, as you heard there. The servo was not settling to its final position for a few seconds. The design of the board that holds it is not quite right. I need to modify it a little bit. But that's not a big detail. I can sort that out with the next design.